Alright, hell yeah. We have material mechanics. We're going to solve this all in one go. It's a problem with the spring, and it's a humdinger, you know what I mean? So the first thing we're going to do is do a diagram of kind of what it looks like, just with dots. I really like that because each dot is kind of where a reaction's at. So hey, we got P there, and then we have a spring, so that's going to be Cy. Same thing here, and then you got By for that spring, and then By for that spring. Cool. So that's that member. You do have a reaction at D, but we're going to sum moments at D. We really don't need to know the reaction at D and A because that's where we're going to sum our moments. So our first two equations are like, hey, sum of the moments at A is 0. So let's do that. These distances are B. Holy hell. Okay, so we're going to go negative C YB minus by times twice the distance, 2b. That's going to equal 0. Now we're going to solve for cy. We can factor out a b and bring cy to the other side. So we got cy is negative 2by. First equation done. Now we're going to sum the moments about d is equal to 0. So we're going to have p times 2b. That's going to equal both these two things. So that's going to be cy times 2b plus by times b. We can factor out a b, and then we can solve for by. So we're going to do that by saying by is equal to, bring this to the other side, 2p minus 2cy. And now we can throw this into this equation. So let's do that. We're going to say cy is negative 2 times 2p minus 2cy. That's going to get us negative 4p plus 4cy. And then we're going to bring this to the other side. So we got negative 4cy plus cy is equal to negative 4p. This is going to be negative 3 cy is equal to negative 4p. We can get rid of that, and we can bring the 3 over here. So hell yeah. So cy is 4p over 3. So now we're going to throw that into, well, let's just throw it into this equation. So we got we got 4p over 3 is equal to negative 2 by. So by, well, let's bring this negative 2 downstairs, get rid of it. So now we got by is equal to, this is going to be 4p over 6. That's going to be 2, or negative 4p over 6. It's going to be, this is negative 2p over 3. So there you go. So we got our equations. These are the force and the springs that we're going to see. If we put a P here, we're going to get the force in this spring to be that, and the force in this spring to be double. And this is double, but it's in tension. This one's half, but it's in compression. So that's a big deal. So now we go to our force of our spring equation, which is the force of a spring is Kx. I like to think of it as K, change in length of the spring. So let's say we wanted to solve for the change in length of the spring. We're going to take the force of the spring divided by K. So let's do that with both these. We're going to take the change in length of spring C is going to be, the force is going to be Cy divided by K. Well, cool. We already know Cy. So that's going to be 4P over 3K. So this is change in length at C. And then, booyah, we can do the same thing for the change in length of B. That's going to be the force at B divided by K. So negative 2P over 3K. Cool. So now we need to get a new sheet of paper. And we'll write what we know. So the force at C is equal to 4P over 3. The force at By is negative 2P over 3. So we know the change in length of spring C is 4P over 3K. Very simple. And the change in length of spring B is negative 2P over 3K. It's just the force divided by the spring constant. So let's get our picture of what the hell is going on again, because now we need to relate. The question says, hey, how far does this thing go down? You know what I mean? This distance right there is delta C, so we need to find that. So let's draw our picture one more time. And hell yeah. So what's going to happen is when we put the load here, this bar is going to go down. And then this bar is going to go down. So here's our 2 bars. And I'm going to label this distance A, B, C, and D. So now we're saying, hey, when we, and we know, so let's figure out the change in length of the spring. So change in length of spring C is going to be, it lengthens here but shortens there. Cool. So change in length of spring C is going to be C minus A. Real simple. Change in, actually, I mean, it's visually not simple, but I think you get it. This one increases in length. This one shortens the spring. So change in length of spring B will be D minus B. And you can see that this one is bigger than that one. So it looks like spring B is going to shorten. This one's going to lengthen. Okay, now we need to show 2 more equations. We need to say that, hey, if I know A, B is just 2 times A. So 2 times A is equal to B, and 2 times D is equal to C. And I think you can see that just by geometry. So hell yeah. So now we have our equations. We got 1, 2, 3, 4, 5, 6, 7, 8 equations, and we got 8 unknowns. 1, 2, 3, 4, 5, 6, 7, 8 unknowns. So now we need to throw them all together. The first thing to do is, hell yeah, put these together, 4p over 3k. So that's going to be the first and obvious thing. So now we got these 2 equations. These are kind of our gold. And then the other equations have to fit into here. What we're trying to find is C. Because back to our picture, if we know this distance C, hey, that's the same thing as delta C. So, and then once we solve for C, that's what it's asking for. Okay, let's do it. So now the question is, how do you actually, you know, if this is what we're solving for, we need 2 equations that have, this equation has C and A in it. This equation has D and B. Let's change this equation to make sure it has C and A. That's going to be the first thing. So D, hey, we can say that D is equal to C over 2. Booyah. And we can say that this A is equal to B over 2. Booyah. So, oh, no, I apologize. No, this B is 2A. Booyah. So let's change this equation. So we're going to go C over 2 minus 2A is equal to negative 2P over 3k. Hell yeah. So now we have this equation and this equation, and both have C and A in them. So let's solve this one for A, and we're going to say, hey, A is equal to, we're going to bring that and then bring that over. So C minus 4p 3k. That's what A is. Let's throw A into this equation. 2 ways to do it. This is negative 2A. So let's just multiply this by 2. So 2a is 2c minus 8p over 3k. Now we're going to say negative 2a is negative positive. So now we have this value for negative 2a. Let's throw it in. So we're going to go c over 2 and then minus 2c plus 8p over 3k is equal to negative 2p over 3k. Hell yeah, let's group our c's. This is 2, if this is 2, this is 2 over, oh, what the hell am I doing? This is 4 over 2. So 4 over 2 is the same thing as 2. This is 1 over 2. So 1 minus 4 is negative 3c over 2. And then we're going to go this one. We're going to go minus 8p over 3k over here. So now, hell yeah, and these denominators are the same. And so we're going to go is equal to, this is going to be negative 10. Negative 10p over 3k. Cool. Now we, to get c alone, we got to multiply by negative 2/3 over here. See how you do that? So we got c is equal to, and we can we reduce? No, we can't, but we got the answer. We got, so the negatives cancel, so we're going to get positive, and we're going to get 20p over 9k. Hell yeah. And I know that was rushed, but that was I've been doing this problem a ton of times to figure out what's the simplest way to get the equations, get the geometry, show that we have all the equations, all the unknowns, and see how to pack them together. And we did it under 10 minutes. Thanks for joining me. That's a video.